Hi, and welcome to Standard Deviant School, Basic Math. I'm Laura Hopewell. Today's program is Integer Grab Bag. We'll be going over some of the different ways to use and look at integers.
Here's the lowdown on what's coming up. First, we'll cover exponents, a shorthand notation for multiplication. Next is order of operations. Then you find out how to round off integers. We'll wrap up with scientific notation, which is used to make working with large numbers easier.
Exponents are a shorthand notation for the multiplication of a number times itself. In other words, instead of saying 5 times 5 times 5 equals 125, we'd say 5 raised to the third power.
The 3 is known as the exponent, and the 5 is called the base. The exponent shows how many times the base number is multiplied times itself.
Here's a couple more examples of exponents.
3 to the 4th power is 3 times 3 times 3 times 3, which equals 81. In this exponent, notice we have a negative number for our base, but that doesn't change the way we find our answer. Negative 5 to the 3rd power is negative 5 times negative 5 times negative 5, and the result is negative 125.
Now, there are a few exponents which do the same thing to every base number no matter what it is. Like, any integer raised to the 1st power is the same as that integer. So 8 to the 1st power is 8. Negative 15 to the 1st power is negative 15.
There's one other exponent that is really important for you to remember. Any non-zero integer raised to the 0 power equals 1.
So regardless of whether the number is 1500 or 2, if it's raised to the 0 power, then it equals 1. One more thing about exponents that you can tuck away in your memory bank. Look at these numbers. Each time we add a 0, we go up one digit place. Now look at these exponents. Each time we increase the exponent by 1, we increase the number of digit places in the corresponding number by 1. This is just a quick note to show you how each digit place in a number increases by a power of 10. Also notice that the exponent number equals the number of zeros in each number.
Exponents are going to be helpful later on when you start dealing with extremely large numbers.
In many arithmetic problems, you'll have a long string of numbers separated by different combinations of operators. You might have to multiply, divide, and add in addition to dealing with parentheses and exponents all in the same problem. Here are some examples.
Don't worry, a standard order of operations has been developed just for these types of problems.
You always work from left to right with these strings of numbers. The standard order of operations is to do parentheses first, then exponents, multiplication and division are next, and addition and subtraction are last.
Lots of people use a mnemonic device to remember this order of operations. The first letter of each word in the order of operation spells PEMDAS.
PEMDAS, PEMDAS, PEMDAS.
Sinking in, isn't it?
Here's an example of a math problem that you must figure out using the order of operations to get the right answer.
5 squared plus 9 minus 3 times 4 minus 8 divided by 2. Now let's solve this puppy. Moving from left to right, we have to do any operations in parentheses first. 9 minus 3 is in parentheses, and it has a value of 6. So we substitute the 6 for the 9 minus 3. So the problem now looks like this.
Since there are no more parentheses left, we move on to the next step in the order of operations, exponents.
Again, moving from left to right, we find 5 to the 2nd power.
Remember, the exponent is just the number of times you multiply the base number by. So we multiply 5 times 5 to get 25. We put 25 where 5 to the 2nd power is. So our problem now reads 25 plus 6 times 4 minus 8 divided by 2.
There are no more exponents. Multiplication and division are the next step in the order of operations.
Starting on the left, the first multiplication problem we find is 6 times 4, or 24. 24 replaces 6 times 4. We continue moving to the right and find a division problem, 8 divided by 2. The answer to this is 4, and 4 replaces 8 divided by 2. So the problem now reads 25 plus 24 minus 4.
Addition and subtraction operations are all that's left. Beginning on the left, we add 24 and 25 to equal 49. 49 replaces the addition operation, so all that remains is 49 minus 4, or 45. So, the answer to 5 to the second power plus 9 minus 3 times 4 minus 8 divided by 2 is 45. Okay? Everyone take a breather.
All right, let's say you've got two big numbers to add, but you don't have time to get your paper out and do a bunch of carrying and so on. Well, then you can round these numbers off. Rounding off is a method used when you're not working with exact numbers. And whenever you round, you do it by digit place.
You can round off to the tens place, the hundreds place, and off to the thousands place, and so forth, depending on your needs.
Anytime you want to round off a positive integer, you have to take 4 steps.
Your first step is to find the digit place you're rounding off to. For our number we're rounding, the digit in the hundreds place is a 4. The second step is to look one digit place to the right of where you want to round off to. If that digit is less than 5, you don't do anything yet. Don't move a muscle. Okay, you can move again. If that digit is greater than or equal to 5, then increase the digit in the digit place you're rounding to by 1.
We're trying to round off to the nearest hundreds place, so the digit place immediately to the right is the tens place. It has a 9 in it. Since 9 is greater than 5, we increase the 4 in the hundreds place, the number we're rounding off to, by 1. We make the 4 a 5.
If the number in the tens place had been less than 5, then we would have left the 4. There's one more step left.
We replace all digits to the right of the digit place we're rounding off to with zeros. We're rounding off to the nearest hundreds place, so we make all the numbers to the right of the 5 zeros. So our new number is 1500.
If we want to round 1,492 to the nearest thousand, then the number would be 1,000. That's because the number to the right of the thousands place is a 4. It's less than 5, so we skip to the next step and replace all numbers to the right of the 1 with zeros.
You can round off any integer, no matter how large it is, if you use the steps we've just talked about.
Another method used to make calculations with large numbers easier is scientific notation. Remember we said earlier that each digit place of an integer is represented by a power of 10. 10 to the first power is 10. 10 to the second power is 100, and so on. In scientific notation, you multiply a number between 1 and 10 by one of these powers of 10. Let's do an example. We'll express the number 2,000 in scientific notation.
2,000 in scientific notation is 2 times 10 to the third power. How do we know this? Well, there's 3 zeros in 2,000. And like we said earlier, the amount of your exponent is always equal to the amount of zeros in your number. So we know the exponent's 3. 10 to the third power is 1,000, or 10 times 10 times 10. Now we just multiply 1,000 by the first digit in the number we're trying to express. In this case, the first digit is a 2. 2 times 1,000 equals 2,000. So 10 to the third power times 2 equals 2,000.
I know all of you out there want to do another. Quick! Represent 400,000.
First, we count the number of zeros to determine what power of 10 you're working with. 1, 2, 3, 4, 5. The number of zeros you have in your number is your exponent. There's 5 zeros, so 5 is your exponent.
Okay, we're halfway there. We know our power of 10 is 5, or 100,000. Now that we have the right number of digit places, all we need to do is multiply 100,000 times 4, the first digit in the number we're trying to express, to get 400,000. So 400,000 in scientific notation is 4 times 10 to the fifth power.
Remember that the amount of zeros in the number is the same as the power of 10 we're raising it by. No matter how large the number is, you can find the power of 10 it's multiplied by if you count the number of zeros. That's why this method comes in so handy for scientists studying vast distances in the galaxy.
Johnson! How are you, buddy?
Eh,
I think I'm gonna build that deck this weekend.
really?
Yeah.
On the back of the house?
Oh, you know it.
How big are you gonna make it?
I was thinking 2 times 10 to the first, by about 5 times 10 to the first. Big deck, big deck.
Wow. You're probably gonna need about 6 times 10 to the second nails for that one, huh? Right? Huh?
Yeah.
Yeah.
And one other thing to remember about scientific notation. Remember that a large number is in scientific notation when it is written as a number between 1 and 10 multiplied by a power of 10.
Oh, like 4 times 10 to the 5th power. 4's between the 1 and the 10.
We've covered a lot of material. Let's have a quick review.
Exponents are shorthand notation for multiplication of a number times itself. And for example, 5 to the third is 5 times 5 times 5. The 5 is the base, and the 3 is the exponent. The order of operations from left to right is parentheses, exponents, multiplication and division, and last, addition and subtraction. Try using the acronym PEMDAS to remember the order. When rounding off, look at the number to the right of the digit place you're rounding to. If it's 5 or greater, round up. If it's less than 5, round down. In scientific notation, the number of zeros you have in your number is the exponent. So 4,000 equals 4 times 10 to the third.
Time to pack everything up and head on out of here. Until next time, I'm Laura Hopewell. Thanks for watching Standard Deviance School.